Have you ever stopped to think about the invisible force that powers our modern world? It's something we interact with from the moment we wake up, a substance so deeply woven into the fabric of our lives that we often take it for granted. It's in the cars we drive, the electricity that lights our homes, and even the clothes we wear. We're talking about petroleum. And today, we're going behind the scenes to explore how this raw material is transformed on a colossal scale inside giant refineries. These sprawling industrial complexes are the beating heart of our energy infrastructure, operating 24/7 to meet global demand. Now, this isn't some simple brute force process. It's a symphony of high-stakes chemistry and precision engineering. It's industrial-scale science, and the journey from a barrel of thick, black crude oil to hundreds of different useful products is absolutely fascinating. From the fuel in our tanks and the asphalt on our roads, to the plastics in our electronics and the fertilizers that help grow our food, petroleum's reach is immense. So buckle up, because we're about to embark on a journey deep inside the refinery to uncover the secrets of how crude oil is converted into the essential products that define our daily existence. When we say petroleum production, we're not talking about drilling for oil that's just extraction. We're talking about what happens after the crude oil, that thick, black, gooey stuff, arrives at the refinery. And trust me, a refinery is no ordinary factory. It's more like a massive, complex chemical city filled with pipes, towers, and furnaces that never sleep. Step 1. Distillation. Our journey begins with crude oil, a substance that's been millions of years in the making. As it comes from the ground, it's a complex, messy mix of hydrocarbons, countless molecules made of hydrogen and carbon atoms, in all shapes and sizes. But it's not just hydrocarbons. It also contains impurities like sulfur, nitrogen, and even trace metals. In this raw state, its potential is locked away. To make it useful for everything from fueling our cars to creating plastics, we first have to meticulously sort this molecular jumble. This fundamental sorting process is known as atmospheric distillation. The core principle is surprisingly simple: separating the components based on their different boiling points. Think of it as a highly sophisticated version of boiling a pot of water, but on an industrial scale. The process starts by pumping the crude oil through a massive furnace, where it's heated to a blistering 350 to 400 degrees Celsius. This intense heat, carefully controlled by operators in a central control room, provides the energy needed to vaporize most of the oil into a hot, pressurized gas-liquid mixture. This mixture is then piped directly into the base of a towering structure, often over 60 meters tall, the distillation column. Inside this column is a series of trays or plates, stacked from bottom to top. As the hot vapor enters the bottom and begins to rise, it starts to cool. This is where the magic happens. The column has a temperature gradient. It's hottest at the bottom and coolest at the top. Heavier hydrocarbons with high boiling points, like bitumen used for asphalt, can't stay as a vapor for long. They condense back into liquid on the lower, hotter trays. Lighter molecules with lower boiling points, like kerosene and diesel, continue their journey upward, condensing on cooler trays further up the column. The very lightest fractions, like gasoline, travel highest before condensing. And the lightest of all, gases like propane and butane, rise all the way to the top and are drawn off. Each tray effectively collects a different fraction of the original crude, neatly sorted by weight and boiling point, ready for the next stage of refining or to be sent to storage. Step 2. Cracking. While distillation is the first crucial step, the natural yield of high-demand products, like gasoline, is simply not enough to power our world. A typical barrel of crude oil might only contain about 20% gasoline naturally. To bridge this significant gap between what nature provides and what the market demands, refineries rely on a powerful process of molecular transformation known as cracking. At its core, cracking is a form of chemical alchemy. It takes the less valuable, heavy hydrocarbon molecules left over from distillation and, under specific conditions, breaks them down into smaller, lighter, and more valuable molecules like gasoline and diesel fuel. The oldest method is thermal cracking, which uses extreme temperatures over 450 degrees Celsius and intense pressure to literally break the molecules apart. A more advanced and common method is fluid catalytic cracking, or FCC. This process uses a fine powder catalyst, typically a zeolite, to achieve the same result more efficiently and at lower temperatures. Then there's hydrocracking, a premium process that combines catalytic cracking with hydrogen. This not only breaks down heavy molecules but also removes impurities like sulfur, producing exceptionally clean, high-performance fuels such as jet fuel and ultra-low sulfur diesel. Step 3. Reforming. Now that we've separated and cracked the oil, we can reform the molecules themselves. Reforming rearranges hydrocarbon structures to make higher-octane gasoline. Think of it like rearranging Lego pieces to build something stronger and more useful. This process helps improve fuel performance and prevents engine knocking thanks to platinum-based catalysts that make the reaction smoother and cleaner. Step 4. Blending. After distillation, cracking, and reforming, refineries have dozens of hydrocarbon streams. These are sent to blending facilities where the final products are created. Gasoline, diesel, jet fuel, each is carefully blended using precise recipes. Additives are mixed in to improve performance, reduce emissions, or keep engines clean. It's part chemistry, part craftsmanship, like a master chef, balancing ingredients to get the perfect flavor. Step 5. Byproducts and efficiency. Nothing goes to waste. Light gases like propane and butane are reused as fuel or sold as LPG. Heavier leftovers become asphalt or ship fuel. Modern refineries are incredibly efficient, transforming nearly every drop of crude oil into something useful. When you look at a refinery, it's not just one machine. It's a network of systems, a dance of heat, chemistry, and precision engineering, all designed to turn raw crude into products that power our daily lives. That shirt you're wearing, the road you drive on, the phone in your hand, all in some way connected to petroleum. Of course, challenges remain. Environmental concerns push refineries to innovate, cutting emissions and improving sustainability. And as renewable energy grows, the future of petroleum is evolving. But for now, petroleum remains a cornerstone of our modern world, a symbol of human ingenuity and engineering power. So next time you fuel your car or pick up something plastic, take a second to appreciate the journey it's been on, from deep underground through fire, pressure, and chemistry, to your everyday life. Thanks for watching. If you enjoyed this deep dive, hit like, subscribe, and tell us in the comments what other industrial processes you'd love to see next. Until next time, stay curious.